Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximise, minimise and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as possible. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Okay, so when we think about Azure, we really built the cloud platform to support all the cloud service models that you might need to build as an ISV or as a developer. And so when you think about those cloud models, they can range from building on core infrastructure through leveraging our advanced workloads like our platform as service capabilities, and then have the ability to have a consistent way to manage those through your development lifecycle, all the way through your deployment lifecycle, and then all of the native management tools that we offer on top of Azure. On top of that as well, not only do we have all of these platforms available natively in Azure, but we allow you to extend this in a consistent way onto your on-premises environment, as well as do hybrid development and hybrid deployment of your applications. And so that kind of gives a complete view of what Azure offers as you start to build native ISV applications or try to take advantage of the services we offer. In today's session, I'm going to mostly focus on our serverless capabilities, but I want to give you a little history or background of what customers are doing today inside of Azure so that you can understand how you build your application, take advantage of what we offer. So when you think about the journey to the cloud, what we see with most of our customers is a lot of them have existing applications and they want to take advantage of Azure. And so they're used to dealing with a lot of their infrastructure as a service in their own local environment using their own Hyper-V or container technology. And they want to be able to bring that into the cloud and take advantage of Azure. And so this is really where a lot of existing applications have a very simple way of moving into Azure. But the challenge with that is you're also responsible for all that infrastructure that's hosting your applications. And so that's similar to kind of where you own your own car, you always have it available, but you're also responsible for the maintenance and upkeep of that. And so as customers start to then think about modernizing their applications and take advantage of the native capabilities that Azure offers, we start to move towards the platform as a service. And with our platform as a service capabilities, we have a unique set of services that allow you to build modern applications and take advantage of the native capabilities for you to do automatic scaling, to abstract away the infrastructure, and to kind of integrate your application across a host of services so that you will take advantage of the work that's been done in Azure, and you as a developer or operations team no longer have to manage a lot of that core infrastructure. And so that's a lot similar to where you're renting a car. You can get those capabilities, but you're still kind of responsible. And if you're not using the car, you still have the car. And so even though you abstract away a lot of responsibilities, you still have some to make sure that you have the car, and then when it's not being used, what do you do with it? And then the last area that we've kind of introduced as customers move even further along the journey is to take advantage of our serverless capabilities. And this is really where it's kind of an evolution on top of platform as a service, where you only use the compute you absolutely need. And then it's given away back to the cloud, and so you're only paying when you need that time. And and similar to kind of a rideshare you would see with common rideshare apps, where you just pay for when you're on there, you get out of the service, and then you no longer use it. And if you need another one, we'll spin it up for you, and you can start using it. So this is kind of the journey that a lot of our customers have gone through over the last few years. And a lot of that is the learnings that we've had as we kind of integrate these three different capabilities together and allow customers to kind of progress their development of their applications onto the cloud. So you kind of have to make these decision points when you're starting to build your applications on what does it mean when I take advantage of infrastructure as a service, platform as a service, and all the way up to software as a service. And one way to think about it is, as you move further up and let kind of the Azure cloud take responsibility for these capabilities, you as a developer or as the operations team no longer have to focus and kind of be responsible for managing those different layers. So when you're on premises, you are responsible for everything from the hardware to the networking, the storage, the servers. But as you start to move into the cloud, a lot of those things get abstracted away, and then that balance of responsibility shifts more towards the cloud and allows you to focus more on the applications. And so that's one way to kind of think about how do I think about my application and how do I take advantage of Azure's ability to kind of manage a lot of these layers for you, and you move up the stack and focus more on the business value. So one way to kind of think about our kind of application modernization is as you kind of want to have more control, so you want to kind of own the infrastructure, be responsible for it, be able to tweak it however you need, similar to like you did on premises. So that gives you full control, but then you're now responsible for all of that. So your productivity goes down because now you're responsible for all the infrastructure management. And so what we'd like to do when you start to build applications is to say, how can I move a lot of that responsibility to the cloud? Yes, I might lose some of the control, but my productivity gains increase. And so this might be where I want to build a microservices architecture and leverage our Azure Kubernetes orchestration capabilities. So you still have some control because you own the containers and how to build those out, but you still allow the platform to kind of do the automatic scaling and the advantages that Kubernetes have. And then as you move kind of further abstraction into our web applications and then finally into our event-driven functions, we actually start to own a lot more of the infrastructure and the runtime, but that means that we're responsible for the updates of that, making sure that we install all the security updates. You don't have to worry about kind of the infrastructure. It becomes serverless, and you're really focused on the business application, the business value that you're providing. And so that's where you see the productivity gains go, but you lose a little bit of the control, and so this is kind of the balance when you're building your applications. And the nice thing about Azure is because we support the whole breadth all the way down from infrastructure as a service all the way up to serverless, you can kind of use the right compute options for your application. But generally, we would encourage you to kind of build at the top layer where possible, because that allows you to really focus on your business value and not worry about the infrastructure. So it kind of gets us into the serverless discussion we're having today. So, a lot of you are probably familiar with serverless, but I kind of want to highlight some of the key themes of what serverless means and how we've actually built Azure to support that. So the first thing we focus on is how do we abstract away those servers? And so the idea behind that is we will manage the infrastructure and all the servers so that you, from the development teams or from the operations teams, only has to focus on your business value and your business processes, not on the cloud infrastructure. The second tenet with serverless is how do I build my applications so that they instantly scale and that they're driven by events that happen inside of my environment so I can respond to those events and then scale accordingly in a reliable way. And then the last key tenet of serverless is you only pay for what you use. So that kind of rideshare is, if I'm not running something, then why am I paying for it? And so this serverless gives you the idea of only when my application is adding value to my business end users am I actually paying for the infrastructure cost that we run. So when you think about those core tenets, it's like, well, what are the benefits for me, as an ISV developer and I'm trying to build applications? So one of the core goals is allows you to focus solely on the business problems. So we're trying to abstract away all the technology challenges and allow you to kind of focus on the business problems. The second key thing that you want to think about is how do I gain efficiency? And so a lot of this is how do I scale automatically so I don't have compute lying around that I'm not using? How do I make sure that my development and testing environment is integrated into my entire end-to-end DevOps lifecycle? And then the last thing is the flexibility it gives you. So this allows you to kind of spin up your application, validate it, make sure it's really working, and so you only pay for that compute you're using. So if you have dev environments, test environments, small campaigns, you get that flexibility of how to deploy those, manage those, tear those down when they're no longer needed, as well as port those across different environments. So let's have a look at this kind of Azure Functions programming model. So to give you an idea of what serverless is and kind of how we approach it from the Azure Functions capabilities. So I talked previously about events, and so when you think about Azure Functions, there's two parts to it. One is this new programming paradigm where we're basically enabling event-based programming. And then we have the serverless infrastructure side of it. And those two key capabilities kind of differentiate Azure Functions from a lot of the competition. And so the idea behind this is as events happen, so you're getting, blobs are coming into Azure Storage, Cosmos DB is coming, you're getting events through Service Bus or Event Grid. How do I actually automatically respond to those events and scale my application to process them so that I can automatically meet my end users' needs, but I only scale when those events require me to scale. And so that allows you to get a very reliable programming model where it becomes event-based. So that calls our code. And the nice thing about Azure Functions is we have a very flexible way of writing your code. So you can use the language you're comfortable in. So if you're a .NET developer, you can leverage all of our C#, F# capabilities. But we also allow you to write in other languages like Node, Java, PowerShell, Python, and others. And then the nice thing about event-based is you get an event, you process that event, do whatever you need to do, and then you can push that into another endpoint because maybe that needs to get further processing by other functions down the line. And so this becomes a very kind of microservices architecture where the function is just doing a specific task, it does that work, and then it moves the result onto the next queue so that can get picked up either by an Azure function or maybe it's getting persisted into some data storage. So from the programming model, again, a lot of what we're trying to do is to abstract away the cost of building these functions so you're worried about the business logic and not worrying about how do I connect into all these different systems. And so how we do that is using a declarative model where we can declare what I want, what event I'm trying to listen to and what kind of type is it and where I want to send the results. So here you can see I specified I want to track that a new item is showing up in the Azure Storage queue, and so that's when I want to get triggered. And I want to send the result out to another queue. And so just with these two definitions inside of an Azure function, you can basically automatically write your business logic here, and then all of this integration into the different Azure storage queues is defined using your function.json. So it's a declarative way to integrate into these systems, and then you're no longer worried about the connection pooling, how do I integrate, how do I learn the SDK for all these different services. We have built our ability to use triggers and bindings to make it seamless to integrate across a whole set of services. So you're really just focused on, I get some input, what is the business logic I need to do, and then send the output using our bindings. So kind of given that background of the capabilities that Azure Functions and Serverless has within inside of the Azure cloud, there's kind of a set of patterns that work really well for these scenarios. And so the first one is around real-time file processing. Another one we see a lot of our customers doing is machine learning. And so, as you build out your machine learning inside your organization, how can I then integrate my application into that in a seamless way so that I can deliver that kind of machine learning capabilities to my end users? Another common pattern we see is around web application backend. So maybe I want to build a single page app. Maybe I want to integrate to my backend services and expose my web applications as an API. All of those capabilities are things we see a lot of customers leveraging functions for because they have that nice auto-scale capability as well as ability to integrate into these backend systems. IoT is another very common scenario we see customers using functions for. And then one of the kind of new things we've also seen our customers do, this is mostly based on challenges customers have around, yes, it's great that we can do these specific tasks, but a lot of times there's long-running orchestrations that has to happen inside of my applications, and what capabilities can we offer inside of functions to make it easier for you to support these long-running orchestrations. And so we built a capability into Azure Functions, which I'll talk about later, called durable functions. So our serverless capabilities inside of functions is not only built to be run inside of Azure, we've actually built it so that it can run anywhere. So we've open sourced all our capabilities, and this allows you to run all of your capabilities inside of Azure, but then you can also bring those and run them inside your local environment, or also deploy them onto IoT devices, or even run them standalone using Azure Stack, leveraging the integration we've done with Azure App Services and Functions. And so this gives you kind of flexibility of where to host my runtime for my functions. But the great thing we tried to accomplish was to really optimize the developer experience so that you get this inner loop capability to author my functions, debug them locally, test them, allow you to gain the benefits of a full integrated dev environment using either Visual Studio Code, VS Code, as well as our core tools and all integration with Docker, so everything can be done locally, and then you can deploy it as you need it into the target environments. And so this is kind of gives you the flexibility to take advantage of the programming model and the auto-scale capabilities, but allows you control on where you want to deploy these applications. So you're probably, a lot of you might be familiar with our serverless capabilities, but there's a few newer things we've added in the last few months to kind of solve a lot of challenges we saw customers when they were building their business applications leveraging functions. And so at Ignite, we launched a new capability called the Premium Plan for Azure Functions. And this gives you the ability to do elastic scale, but it opens up the new scenarios that really weren't that possible using the existing Azure Functions capabilities. And so a few of the challenges we tried to solve when customers were building these applications was if you needed more compute or more memory when you were running your application, how could we give you the ability to support that? And so that was one thing. Now we've opened up the ability for you to select the type of compute you want your functions to run on. The kind of common complaints out there around functions in general, is that there's always this cold start because I'm only paying for when it's running, and so there's always this kind of a initial startup time that everybody pays and everyone tries to reduce so that you can remove what that end user experiences when they call those APIs. And so one of the things we've offered inside our premium plan is for you to remove cold starts by always having a pre-warm instance available for you. The third area that we focused on was allowing you to integrate more natively into your virtual network environments. And so if you have VNets set up inside of your Azure environment, and they may even reach back into your on-premises environment, we now allow you to bring functions into that same virtual network, and then you can connect into everything that's protected inside of that network, but also reach back into your on-premises environment using the same technology. And then again, obviously when we're building functions, one of the things we promote is to run these short functions that, process, one task and then kind of send on the results and have another one process one task. But there are certain scenarios where you need to have it run longer than that. Maybe the endpoint you're calling, you have to send a lot of data at once and it's transactional and you kind of have to do a single call. And so there's a lot of scenarios customers run into where they just couldn't get it to run under 10 minutes. And it was becoming a struggle where they had to kind of re-architect their application. And we said, let's just solve this at the platform level so that you can still take advantage of all of the serverless capabilities, but we will let you run things longer. And so now with Premium, we allow you to run up to 60 minutes instead of the previous shorter time we offer if you just use the standard plan. And then the last thing we wanted with Premium was where you could specify how large you want our auto scale to go to. And so this, kind of potentially offered predictability into building, but also reduce kind of runaway functions that might exist where they kind of kept on scaling. So now you can kind of enforce a certain amount of minimum and maximum sizes of scale you want the function service to perform. Okay, so some of the scenarios that I talked about that kind of open up with the Premium is if you're having compute-intensive capabilities like image or file processing, often they can't be done in the limited compute that's offered. And so you want to be able to select a larger compute to be able to do that processing. Similarly, if you're trying to do like machine learning inferencing, a lot of times that is compute heavy. The other one I talked about was how to reduce that cold start. So there's a lot of scenarios and applications like I'm trying to expose APIs to my end users. I have line of business apps that have to respond automatically. And so you want to be able to remove that latency that normally exists with serverless by taking advantage of Premium. And then the last one I talked about was, there's a lot of applications that need that network isolation like finance, healthcare, but even internal facing tools that you need to be able to connect into. All of that opens up with Premium and the ability to kind of integrate into your own virtual networks and then have everything controlled using your existing operations. Okay, so with that, I'm going to kind of switch over and just give you a demo of Premium functions inside the portal. And so you can kind of see some of the capabilities it offers and kind of walk you through how you can adjust each one of those capabilities inside the function. Okay, so here you can see I have a Premium function app that I've built. And there's a few things I want to call out inside of here. So the first thing, you can see that it's Elastic Premium, so it's no longer the consumption plan. And so this opens up a set of capabilities inside of your function app. So the first thing you'll notice is we now offer the scale-up capability. So now you get the ability to pick kind of the different SKUs that you want to use depending on the scenarios and business application you're building. So if it has compute intensive or memory intensive, you can now select that automatically by scaling up the instances. And then the other core capability we talked about was the automatic scaling. And so here you can see that just to remove all of that cold start, we always have one instance available. And so there's always going to be a minimum of one instance. But then you can control what the maximum burst is as well. So you can burst all the way up as far as you need. But you get the controls on how many instances of compute we should spin up to support this function app. And then also we also give the ability to do pre-warmed instances. So we're going to have the one instance available, but maybe your steady state for your app requires 3 or 4. And so it's good to kind of specify the limited number so that you always know this amount of compute is there because that's what's needed to serve. And then only scale out when I get those bursts of activity coming from my end users who are accessing my app. So that's kind of all of the scaling capabilities that we offer inside of there. The other option then you get is all the networking as well. So now it opens up networking, and you can do hybrid connections if you have environments where you can't set up virtual networks, but you still need to be able to connect into those, or you can just do virtual network integration, which gives you secure access to resources across your entire Azure VNet, even if those are inside of Azure or extended into your on-premises environment. So I wrote a simple app just to kind of give you a view of what this looks like when you run it now inside of a premium plan compared to a consumption. So this is a very simple application that basically just takes a couple of parameters: what's my starting location, my ending location, and when I'm going to go. And so what I can do is just run this. And so what you'll notice there is it ran immediately. So the cold start is basically gone when I start using the premium plan. So now I can offer this API out to my end users, and I no longer have to worry about cold start associated with this application. And so again, only with a few lines of code, you can see here, this is basically the get directions. I'm leveraging the Microsoft Bing API, and I'm just calling the response, and then print out the results automatically here. So you can kind of see how this input works. So that's where you kind of show the removal of cold start, and that's one of the scenarios around exposing it as API endpoint. Obviously, if you're doing different types of scenarios that require more compute or integrations to networking, you can set those up seamlessly and then take advantage of those as well. The other area I wanted to call out, because we did some integration over the last few months, was to, if I want to expose that API out to my end users, I can bring in API management. And then API management has a new consumption plan that they offer so that you can match maybe consumption you're doing on functions, but they also have the premium one that you can perform. So if I go into Post, now you can see there's native integration inside of the Azure Functions experience to develop your APIs, test them, manage them, and then take advantage of all that API management has to offer when you're controlling your applications. So there you can kind of run it here, get the results, and it'll work exactly the same way as if you were calling it externally inside of the Azure Functions directly, but now you're going to call it through APIM. Okay, so that gives you all kind of the core capabilities we offer inside of a premium application, and then hopefully you can see some of the benefits that we give over the normal serverless capabilities you might have been used to in the past. Okay, so let me switch back and continue with the slides. Okay, so a couple of other capabilities we offered beyond Premium recently was we continue to enhance our durable functions capabilities. So if you remember earlier, I talked about some of the challenges customers have using traditional serverless functions is it's hard to write orchestration on top of those. So if you have long-running orchestrations, your application has state, how can I take advantage of all the programming model and the benefits that serverless gives me, but still be able to perform these operations that my application needs? So there's a whole set of patterns that we offer inside of Azure Functions using Durable. And so there's scenarios around function chaining where I have a sequence I need to call. So one activity I want to call, and then when that finishes, call the next activity. And it's kind of difficult where everything, where there's no state and there's no way to kind of manage how the sequence happens. And so with Durable, we offer that as a pattern very easily inside of functions. Similarly with async HTTP calls, so when you call an API, you want to get a response straight away because you can't hold on to connection for 5 minutes. It'll just time out. So you can send the QO2 back, and then you'll actually get the call back so that when the call is finished, you can get the results. Similarly with fan in, fan out, so if you want to run a bunch of things in parallel, then aggregate the results back to those, that's another very common pattern that Durable is used for. Similarly, if you have a long-running monitor where you're always checking an endpoint, it's very good for that because you can continuously call it, get the results back, and then take action based on that monitor. And then the last couple we have is the human interaction. So this really opens up the long-running capabilities inside of functions as well, where you can basically perform some action, and then now you need some approval from some end user, some other human interaction that has to take place before I continue and call my next function. And with Durable, we make that very easy to perform. And then the last one, which is a new one we added over the last few months, was event integration. And so this allows you now to basically collect state from all the different resources you're trying to manage and store that state into the Azure function. So now function itself has state, and so you can basically create an entity for each of the resources you're trying to work with and store the state on top of those. So the other thing that we've kind of started from the beginning was, how do we make sure when we build out serverless with Azure Functions that we can make it available to customers no matter where they're running it? And so one of the real benefits of moving to serverless and moving to Azure Functions is we made sure that everything was open source so that not only do we get the community engagement and the feedback early on when we built it, it allows the community and our customers to deploy it wherever they want. So if they want to run it locally in their own Kubernetes environments, not in Azure, they can still take advantage of all of the runtime, all of the programming model capabilities. But then once they're satisfied, it's working well for them, maybe they want to take advantage of the cloud serverless capabilities, they can seamlessly move those over because we have a standard way to deploy your functions anywhere you want to run them. And you can see there on GitHub, if you go to Azure/Azure Functions, all of our repos are open source. You can see the community engagement. You can download them. You can leverage them inside your own local environments, or obviously inside of the cloud as well that Azure offers. And one thing we recently launched as well was a capability inside of Kubernetes called Kata. And what this allows you to do is do that event-driven auto-scaling just like we do inside the cloud. So obviously in the cloud, when new items show up on your queues, or some other Cosmos DB comes up, or Service Bus, and all these different events are happening, we have a knowledge of, oh, you're starting to queue on those services, so we just spin up some more compute so that your functions can catch up and process those. So all of that is taken care of for you inside of the Azure cloud. But if you want to run everything inside of Kubernetes and run it locally or inside of Azure Kubernetes Service, we have a capability called Kata that does a very similar action for you, but it integrates natively into the Kubernetes capabilities, so you can take advantage of event-based programming inside of your own Kubernetes environment. So that's kind of a new service that's available inside of your Kubernetes ecosystem. And obviously, it'll scale back down to 0, which is one of the real benefits of using serverless. And you can get a link there on github/katacore/kata. So one of the newer areas that we've seen a lot of customers ask about is, yes, I'm building a lot of my applications, and serverless is really good for that because it opens up all this flexibility and productivity. But I also am not just building applications, I also have to manage those applications. So how do I make sure that I can deploy them, I can secure them, protect them, monitor them, configure, govern? So the entire Azure lifecycle, not just of your application, but your infrastructure, can also benefit from an event-based serverless architecture. And so what we spent the last few months was thinking about all these different scenarios customers are trying to build, and they come up with a way to allow you to take advantage of the platform, but take it for operational tasks that your application needs, not just the application business logic itself. And so that's one of the new areas that we wanted to open up with event-based automation that we've now exposed inside of Azure Functions. And so what this opens up really is the ability for customers to think about all of the different automation needs I have across my infrastructure and my application. So how do I deploy my infrastructure and my application? How do I respond to events that happen after my application or my infrastructure is deployed? And then how do I integrate and orchestrate into my own monitoring systems perhaps? Perhaps I have my approval systems. Perhaps I'm using GitHub. How do I integrate and kind of orchestrate all those different capabilities? And so we have a set of native Azure services that we've built inside of Azure for the last few years around like GitHub capabilities like GitHub Actions, Azure DevOps, Azure Deployment Manager, desired state configuration, policy, resource manager, blueprints, and then functions and logic apps, which is really the serverless capability where you get to define your own code and your own logic and then have it respond to all these events that are happening across your infrastructure. And so what we've seen over the last few months since we launched at Ignite was customers are really starting to adopt event-based automation as a new way to kind of build that logic and put it inside the system so that as the system responds, your automation can respond to it. So one of the reasons that we've kind of invested in this automation space over the last few years was there's kind of a set of criteria that we heard from customers as they start to build out their automation. They start to move some of their applications into the cloud. One obviously was the DevOps model, which has been around for a while, but when you start to get your development teams and your operations teams working very closely together, we want to make it very easy for them to share their knowledge back and forth. The other thing we've noticed is there's no longer this large separation between your development teams, your application teams, and your IT. You know, where traditionally, like the application teams would build their app, then they would hand it over to the operations teams, and then they would have to do all their reviews, all their analysis, and they would decide how to deploy it. And there was this kind of going back and forth of who's responsible for what. Whereas now the new model is we want to share that responsibility between the application teams and IT. And then obviously, the environments are getting a lot more complex. As you start to move things into the cloud, there's a lot of native services now that you have to be aware of, but also those may be reaching back into your on-premises environments. How do customers, solve the problem of complex environments and be able to integrate and orchestrate all the different infrastructure and applications? So how we try to solve a part of this, which is the event-based automation capabilities in Azure Functions, was let's make sure we can try to get a common platform where the development app teams and the operations teams can work together using the same tooling, the same experience. We'll try to build it for the skill set and the knowledge the operations teams have, but also leverage all of the development capabilities we've offered inside of Azure Functions. So one of the ways we tried to do that was to offer more operational type language support into Azure Functions. So at Ignite, we just launched PowerShell, and then Python as well is now generally available. So now the typical languages used for automation are natively supported inside of Azure Functions. And then the last thing we did was we have a lot of capabilities with our triggers and bindings to kind of trigger off application events. So things that might be happening in queues or in Cosmos DB or through Event Grid. But there's a lot of operational events that are happening across your cloud as well, and how can we react and get triggered for those operational events? And so things like, building on Event Grid because it tracks all of the resources getting created in Azure. How do I get notified from Azure Monitor when an alert happens? All these different sources of events that are more operational based, we actually made sure we had integration into all of those using Azure Functions. And so kind of the 5 patterns that I would look for when you're doing event-based automation, this is where kind of a lot of customers were struggling with in the past, and hopefully we can try to solve those leveraging the serverless capabilities for operational tasks as well. So obviously you want to be able to respond to events on resources. So if someone just deleted my SQL database, I want to get notified. Someone just scaled my virtual machines, I may need to get notified and update my configuration management database or whatever kind of response you need to those resources that are happening. Obviously, there's a set of scheduled tasks that you need to run. So maybe you have a nightly set of operational tasks you need to run. You can leverage those inside of the platform. You want to process alerts. So you want to get notified every time Azure Monitor gets a metric or a log that you want to process. You can actually integrate natively into the Azure Alerts capabilities. If you're using integration into third-party systems, then you can leverage that logic apps to connect to those systems because they have all the connectors for external systems available, and then call into Azure Functions to process the request. And then obviously, even inside the operation, you want to kind of, a lot of times, expose some operational tasks that the logic's being built, and then you can put all that logic into an Azure function and expose it out as a webhook or an API. Okay, so some of the scenarios that we see a lot of our customers doing is, a virtual machine gets deleted, removed from the monitoring system, or if a resource group gets created, then I want to know what cost center to apply so that they can get billed for the usage of that resource group. Or I want to get integrated into Azure Active Directory so that as new SQL servers get spun up, I want to automatically add the right group for access to those SQL servers. So these are kind of a lot of operational tasks you do across all of the Azure services, but now you can build that knowledge using automation directly into the platform. And so as these things happen, we can respond to those and apply the right business logic from your automation kind of operational perspective, not just across your business logic. And similarly, the whole set of operation tasks like with CPU spikes, send a Teams event when I store the key, account latency is greater than 50%, open up skid issues. So everything you do for an operational task that kind of follow those 5 patterns, they can now be codified using the native scripting languages you're comfortable with, like PowerShell or Python, and make them available. So one of the things we launched just in November at Ignite was PowerShell support. So I wanted to touch on that because it's kind of the latest language we've brought into Azure Functions to kind of open up these operational tasks. So it's basically built using all the latest technology that PowerShell has. So PowerShell Core 6, and then we will support PowerShell 7 as it comes out later this year. But we've actually built a lot of ways for you to manage all of your modules natively inside the service, but then ensure that all of the PowerShell language syntax around logging and tracing, integrate just that natively into application insights so everything flows seamlessly. Just as you might be monitoring your application, you can now do the same monitoring inside of your automation as well. And then because of the integration with Premium, and you can run these PowerShell, you can now connect into your own on-premises environment using virtual networks or through hybrid connections. So the whole kind of set of capabilities that once we brought PowerShell in, we wanted to make sure all of those operational tasks would work across your not just Azure environment, but your on-premises environment as well. Okay, so I'm going to switch over and kind of give you a demo of our event-based automation and what that looks like. Okay, so here you can see I have a function I've built, and I'm going to show you how it supports PowerShell support, but also how we've done the native integration so that you can do your automation across events that happen inside of your system. So what this scenario does, a very simple scenario, but a very powerful one, is every time I configure an Azure alert, I want that alert to call my Azure function because I'm going to process that alert. And in this scenario, I'm going to send a link into Azure Teams so that if I'm using Teams as my environment to kind of track issues, get notified, you will actually get notified directly inside of that Teams channel, and then you can respond to it as you're needed. So this one you can see it just processes the alert, and then it connects directly into Teams and fires off a webhook, as you can see at the bottom. So just a few lines of code. You've now kind of integrated your workflow inside of Teams into the monitoring system that Azure offers natively. And how that's done, basically, is you can go in and configure one of these alerts. So what I've configured is every time I get a HTTP server error, and it's greater than 0, then I want to get notified. So that allows you to kind of set all these conditions that you want inside of the application. And then when those events happen, so you can see I triggered one earlier, then I want that to call my function and do some work. So here you can see I basically said, when this event happens, call my trigger function for failed functions action group, and that action group calls my function. So this allows you to kind of integrate natively into Azure, all the Azure monitoring capabilities, but allows you to perform that custom action that you want to happen. So maybe you're going to do automatic remediation, or maybe you're just going to escalate it into a third-party system like Azure DevOps or GitHub, or maybe into ServiceNow by triggering into Logic Apps. All of those scenarios are now opened up because of this native integration we have. Okay, so that's kind of how the PowerShell capabilities work. And the nice thing about this is all of the benefits I previously talked about Azure Functions, you also inherit when you start to bring PowerShell experiences into event-based automation on functions. Okay, so let me switch back to the deck. Okay, so when we think about the building serverless applications, you're going to think about how do we kind of integrate across the entire Azure ecosystem. And so I talked a little bit about, the different serverless capabilities we have. So obviously Functions has the ability to kind of write your own code, respond to those events, and you control exactly what you want to build. So if you're building, microservices architecture, APIs, do machine learning, all of that knowledge and code can be built into these Azure Functions. But obviously we have other serverless capabilities as well, like logic apps. So if you are trying to create workflows or integrate into third-party systems, native integration across those two systems allow you to take advantage of both of them depending on what you're trying to accomplish. And then I briefly talked about our Event Grid investments. And so the nice thing about Event Grid is we have direct triggers with Event Grid, so you can now publish all of your events into Event Grid and then trigger functions based on those. So obviously Event Grid has a lot of native ones built into Event Grid out of the box because of our native integration into Azure services, like storage, you might get Azure resource changes, all of those natively come in, but you can also publish your own and then react to those using functions. And so all of that kind of is built on a common platform, and we integrate into everything you might be building inside of Azure services. We generally have a way to get triggered based on those events, as well as to integrate and store your data onto those back-end platforms. And then the other thing I wanted to kind of highlight was the development model that we built really allows you to focus on building your application, testing it, ensuring everything is good in your local environment because of our open source capabilities as well as our direct integration into VS Code and Visual Studio. So all of that local development experience can happen outside of Azure, and then when you publish it, you really take advantage of the serverless capabilities inside of Azure. And so we think we really have a nice system where you can build these business applications very quickly, but then also scale them out to additional applications leveraging the same infrastructure and processes you have. So if you leverage Azure DevOps or Azure GitHub to try to do tasks, we have native integration built into those as well. Okay, so this was kind of wanted to go through how we think about building applications leveraging our serverless capabilities inside of Azure. And so I think the main thing to think about is if your application can work on serverless, then you really should start thinking about how do I take advantage of that? What are the kind of scenarios? What are those applications I have that are really designed around event-driven design patterns? And so the machine learning ones I called about, serverless APIs, event-driven automation, long-running, using durables. There's a whole set of patterns that we've talked about that if your application is one of those, or perhaps you're trying to extend your existing application, which may still be running inside of virtual machines, but you want to add more value, then you can kind of add this microservices capabilities using serverless to those existing applications. And if you want to kind of get started, I had some links throughout the deck, but I try to summarize them here where obviously, you can go to azure.com/functions to get information about the service. But if you want to get involved from the community perspective, you can also go to our GitHub account and see all of the activity that's happening out there. And then lastly, one of the things we added very early on was a serverless library so that all of the community content that's being generated around Azure Functions and serverless can be uploaded so that other customers can benefit from the content and samples that are up there. And so that's available from our serverlesslibrary.net, and we would encourage other people to continue to add more content up there. Okay, so I think this is one of the last slides I have, which is resources that you can use to learn more about Azure Functions. And if you're trying to get to see what's happening with CADA or how our Azure Function Host works or the community library, all of these resources are available in this single slide for you to learn more about our serverless capabilities, but also think about some of the applications you might want to build and are they good candidates for leveraging serverless, PaaS, or IaaS. So with that, I will switch over to the questions and answers, and thanks everyone for attending this webinar, and hopefully you've learned something about building applications, leveraging our serverless capabilities inside of Azure, and specifically using Azure Functions.
We hope you enjoyed the webinar, and we will be sticking around for a few minutes for a Q&A session. We have some Microsoft experts on standby to answer your questions. To ask a question, simply type it into the chat window and we'll get to them as quickly as we can. You'll also find a resources widget in the bottom middle of your screen. In there, we've put additional links that you can use to supplement your learning. Lastly, we're always looking at how we can improve this experience for you. We'd love it if you could fill out the survey found in the survey widget located at the bottom middle of your screen. If you're not joining the Q&A session, thank you for attending and we hope you have a great day. Thank you for joining us, and we do hope you found the sessions interesting. Have a great day, everyone, and we'll see you at future Microsoft events.